Hello, everyone. Welcome to our today's webinar. Thank you for joining us for this small session where we will be talking about the WindCube Insights Analytics software. My name is Elvira Aliverdieva. I'm a product and offering specialist at Vaisala, and I'm joining you today from our Vaisala France office in Paris-Saclay. In today's webinar, we will be talking about the data analysis tools that we can provide to support your lidar measurement campaigns. And we will specifically focus on the WindCube Insights Analytics, which is a cloud-based data analysis software designed for simplification of the power curve calculations. I will do a small introduction, and my colleague Chi will then walk us through the software to show its main features. Just before we start, let me briefly introduce myself and Chi. So on my side, I graduated from a SEC business school in France, and I then joined Vaisala's product marketing team, where I work together with our product managers to develop lidar market positioning. Today, we will also hear from my colleague Chi Liang, who is an application manager for WindCube Nacelle lidar. Chi is focusing on the data analysis, algorithm development, and lidar applications in the wind energy. He received his master's degree in atmospheric physics and atmospheric environment in Peking University, and he's currently pursuing a PhD in wind measurements and wind simulations. All right, so let's now look at the power curve data analysis and how Vaisala can support customers in this area. In fact, we see several challenges and needs in the market today when it comes to data analysis. First of all, for some of our customers, the challenge may arrive at the very beginning of the data analysis, as they often lack tools to synchronize various data sets collected during the campaign. In addition to that, there are often complicated procedures to filter the nacelle lidar data and the turbine data, which also becomes more complicated with the application of the IEC standards and industry best practice. And actually, to do data analysis, the lidar users often require additional software or tools to do data analysis and bring this data in one place, which takes time and is not always very intuitive. And finally, many of these nacelle lidar users often need to perform additional types of measurements to determine, for example, the yaw misalignment or nacelle transfer function. All of these challenges often make perform data analysis after the measurement campaign. So keeping this in mind, we believe that WindCube Insights Analytics does bring additional value. First of all, the software simplifies your data set synchronization with just a few clicks, and it also helps you to select a specific sector of the lidar measurements for your analysis. The software also simplifies the overall analysis steps by combining the three data sets that are usually used during the power curve verification. So the nacelle lidar data, SCADA data, and the reference OEM power curve. And just as importantly, we are also following latest IEC standards and break down the calculation components according to the specific IEC to simplify your power curve calculations. And actually, thanks to this step-by-step approach, the software users are able to compare the final power curve with the reference power curve and identify underperformances. The software can also display the final IP table per different wind speed distribution, and all of this is also standardized. And then finally, the software also allows for additional performance improvements and provides recommendations for yaw alignment and nacelle transfer function corrections. And so these are the 5 main applications that we will be looking at today. This will be the end of my presentation, and I will now turn it over to my colleague Chi, who will do the who will present us the software in a bit more details. So over to you, Chi.
Okay. Hello, everyone. Thank you, Olivia, for the introduction. Let me first share my screen. Now I will go ahead and demonstrate the main features of this software and how it helps you perform the analysis for the power curve. So this is the software interface for your login, because this software is the cloud-based. So you can log in by the email account. Yeah, and after you log in, you can see there are several data sets under your email account, and there are several data sets is all your existing measurement. So let's take one data set for example. Yeah, there is 5 applications which you can use for the data analysis. So first one is data synchronization, and also the sector analysis, and the power curve analysis, and also nacelle transfer function, and also your offside. Before we go into each one application, I want to show you how you can add some description for the data set, and how the data file you need for your analyze for the power curve. So let's click on the compound name for one measurement. Yeah, so here is some detailed information for this data set. You can see here some general settings for the name and the site, and some detailed description for this data set. And you can also define the start date and the end date for the measurement. And also there are some site wind resource assessment parameter. The Weibull factor, which we can use to evaluate the annual energy production for the power curve at a different site. Yeah, and here we can have some information like for the wind turbine, like the model and the hub height and the rotor and the other parameters. Yeah, and here we can to add some description for the lidar itself, like the position of the lidar. Yeah, so after we added some detailed information for the data side, we can go to the data file. In this web page, all the data file used for the which you upload to the software is listed here. We need 3 data file for the analyze. Here we can see the original data file. This one is the lidar data. All the data is CSV format, and here this one is the SCADA data, and this one is the power curve data. Yeah, if we can see some detail, there are the horizontal wind speed and hub height, and also the wind direction measured by the lidar, and also there are other parameters which are available for the filtering and sounds analyzed in later. And here is the SCADA data. You can see the power curve, the power data, the power output of the wind turbine is the most important one. And also there are some status which we can use to for filter the wind turbine date. Yeah, and this one, the last one is the power curve, the reference power curve, which provided by the OEM. So yeah, all the data file we need to we can to upload in this page, and we can have some log information if there are some successful login to upload to software, or maybe there are some worrying about something. You can know how the data file is for the analyze. So after we added the description and uploaded the data file, we can go to the analyze of the software. Yeah, the first one is data synchronization, and the second one is sector analyze. There are two primarily analyzed for the power curve because we need to synchronize the data file of lidar and also the data from the scatter to make it is perfect synchronized. And also the sector analyze could know because the tax turbine is affected by some effect from the surrounding wind turbine. So we need the two sectors to filter the data. So let's go to the data synchronization first. Yeah, after we click here, yeah, we go to the interface for this function, and we can update the view of the figure. So we can see there is a 2 time series plot for the blue one is for lidar itself. The red line is for the SCADA data, and we can see from the figure that there is the timestamp for the SCADA data and also the timestamp for the lidar data. So we can find the time shift very easily. So we added the shift size here, and we add to the data file. And here we can see after we shifted the date, the two the time series is perfectly synchronized. So this is very important for the power curve because we may have several data measurement for each data site. Maybe the shift value of the time is different. So it's very easy to make sure the time synchronization is right. And yeah, so after we synchronize the times, we can to analyze the sector. Yeah, and here we can view the date. Yeah, so we can see the measurement of the lidar. The x-axis is the yaw value from the wind turbine. The y-axis is the relative wind measurement by lidar itself. So we can do some filter we can add it here the start date and end date for the measurement, and also we can exclude some period which maybe the measurement condition is not good, and yeah, maybe some issues for lidar or maybe from the wind turbine. Yeah, and here we can to filter the date when turbine is not when turbine is shut down. Yeah, so we can see from the figure very directly that for this phenomenon, the wind direction is jump up and down. So this is the wind sector is affected by the surrounding wind turbine. So here we can easily to do some sector management, like to filter the wind sector from maybe 100 to the end of the sector. Yeah. And also we can see there is a very smaller data in this wind sector. So we can also filter this wind sector data out. So we can add it here also, like maybe 0 to 45. Yeah, we can add it here. So after we find the suitable, this is the main suitable wind sector, which is good for the power curve analyze. Yeah, so first the two steps are very important to know the time series plot is synchronized, and also wind sector, the right wind sector is used. And then we can go to the detail for the power curve analysis. So we can use the apply to view the row measurement for the power curve. Yeah, let's have some times. Yeah, this is the scatter point for the row data of the power curve. So we can see the y-axis is the lidar, the free wind speed, which is measured by the lidar. The y-axis is the power output from the wind turbine. So we can see there are some data point, which maybe is the turbine is not is not generate the power. So we can use the filter to filter the bad data. And here we can also to filter the period. Also some we can not use some bad period. Yeah, and also we can filter the turbine which is not generate power. And also we can here to choose the right wind sector. Yeah, here we know that for 0 to 45 is not good, and also 100 to 360 is not good. Yeah, we can add it here. And also this one is for the because the IEC standard because the wind turbine maybe is not under the standard conditions. So we can use this one to correct the power curve to the standard air density, which is required by the IEC 12.1. Yeah, and also here is we can to filter the data by lidar itself, like use the suitable range and also some threshold for the data availability, and use the range value for the wind speed and also for the wind direction, and maybe for the more the filtering for the lidar, like the CNR range and the TU and the TI range, and also the Shen and the VIR. So here, after we filter the data, we can have the very good power curve measurement for the which we want to use. And we want to mention something here is that for the IEC 12.1, the uncertainty calculation is very complex. And also the value for the uncertainty calculation is also a little complex. So we list all the uncertainty component which is required by the standards, and also give some default value, which we easily for you to combine the final uncertainty for the power curve, like the some uncertainty for the power output and for the wind speed measurement, and also the uncertainty for the fluid distortion and temperature and air density, air pressure, and also humidity, and also the uncertainty for measurement method. Yeah, here we want to highlight here is that because the new standards which are dedicated for the NASA mounted lidar is the IEC 50.3, which is officially released in the beginning of this year. So we can use the uncertainty which is mentioned by this standard, like the uncertainty for the wind reconstruction, and also other parameter, and also the operation uncertainty, and also the uncertainty due to the measurement height is varied due to the lidar, the nacelle is tilted, and yeah. So because to the NASA lidar, the verification for the lidar is normally for the length of sight. So we can use this one to propagate the uncertainty from the length of sight to the wind for the final uncertainty for the wind field reconstruction. Yeah, we can here to add the uncertainty for the length of sight and the sensitivity for the length of sight. We provide some default value, which is provided by the third party. And also, if you think if you want to use your own verification, you can directly change the value here. So the final uncertainty will be changed accordingly. Yeah, and here we can see here for the measurement, we can see this one is the mean average for the power curve, and also here the right line is the reference which is provided by the OEM. So we can see for some wind speed, the two power curve is very close, but for some wind speed, the real power curve is a little underperformance for this wind speed. So we can easily combine the real power curve and with the reference power curve. Yeah, and also we can see the power curve in the table. Here is the measurement. Yeah, so the cut-in wind speed is from the 3.5 meter per second. So we can see here. Yeah, this column is for the power curve, the average power value, and here is the data sampling numbers for each beams, and also the uncertainty for catalog A and the uncertainty for catalog B, and the final uncertainty for the power curve. Yeah, so also we can see to evaluate the AEP for this wind turbine at some different annual average wind speed. For example, if the wind speed is 6 meters per second, the power curve, the turbine will generate some like some annual AEP like here, and also the uncertainty for the AEP. Yeah. So after we've the software also provided two additional analyze function. This one is for the Nacelle transfer function, and this one is for the yaw offside. Let's go to the Nacelle transfer function first. Because the Nacelle transfer function from the wind turbine may be shifted due to the time. So we can verify the Nacelle transfer function is good or bad use this software. So this is the rule measurement for the Nacelle transfer function. And here we can also do the similar filter like for the power curve. Here we can to choose the good time, and also the filter the wind turbine start down, and also the to filter date by lidar itself, and also do some sector measurement which is similar to the power curve. Yeah, after we use we apply the filter, we can see the Nacelle transfer function is very easily to to show in the interface, and the formula we can see from here. Yeah, so we can also to analyze the yaw offside for the wind turbine because the wind van of the wind turbine is behind the blade, and also may be affected by the surrounding structures. So we can here to analyze the yaw offside for the different wind sector. Yeah. Here we can use apply to see the measurement for the yaw offside. Yeah, the left figure is the value for yaw offside, and the right figure is for the convergence of the calculation. So we can see easily that from the different wind sector, the yaw offside is different. And here we can do some filtering here. And also we can to choose the sector size. Like maybe we want to use the 30 sector to have the yaw offside. So this software will make the analyze more easily and use for you. So as a conclusion, so we can see from the demo presentation that the WindCube Insights Analytics allows to perform quick and simple and transparent power curve analysis with IEC compliant filtering and also AEP calculation. It allows for the upload for the WindCube Nacelle and the SCADA data with a very simplified data synchronization process. And also there are many filtering for the data are available in the software. And also this filter is very standardized and fully configured in the software. So it's very easily for different people to analyze the power curve. Okay, that will be the end of my demo presentation. Thank you for your time and your attention. Olivia.
So thank you very much for this demonstration and showing us all the main features of the software. Indeed, the WindCube Insights analytics software provides great data analysis and reporting capabilities, bringing the lidar data and turbine data to one place. We are also curious to hear the feedback from existing software users. So do let us know what you think and how we can improve the data analysis step even further. So it looks like we've covered everything we wanted today. Thank you, everyone, for showing your continuous interests. Please don't hesitate to send your questions to us if you have any. We will be happy to follow up. So have a great day, everyone, and see you next time.